Wellness by Designs, and I'm your host, Andrew Whitfield Cook. Joining us today is Dr. Barrie Tan, a PhD biochemist and chemist, and the discoverer of tocotrienols. And I'm excited to speak to him today about these because I don't understand much. Welcome to Wellness by Designs, Dr. Barrie Tan. How are you?
I'm well, thank you. Nice to be on your show, Dr. Andrew.
Now, I was excited to learn that you are indeed the discoverer of tocotrienols. I thought you were an expert. So can you take us through a little bit of your history up to where you discovered tocotrienols? Because my history of vitamin E was that it was originally extracted from wheat germ. Is that right?
Yes, there were a lot of studies at the beginning that were extracted. Wheat germ was because it had a huge abundant source. Its original discovery of vitamin E itself was from spinach because of two
Oh,
pediatricians it's not a lot in spinach, but these two pediatricians were studying it in rats to bring the fetus to full term, and that's why vitamin E is a birth vitamin. Most people may or may not know. It may know them as an antioxidant, but not as a birth vitamin. But it became a vitamin because of the ability to bring it to full term. And then also for the beginning, I'm not exactly the person that discovered tocotrienol. Instead, I discovered a pure source of tocotrienol directly from plant, and the plant is called annatto. If I tilt my head a little bit, I'll come back to the same place. So don't get. If I tilt my head for a little bit, you see in the back here. See here, that is
yep,
from the
yep,
annatto. That is from the
yep.
annatto plant. I also discovered this special vitamin E from palm and also from rice. So that's my really claim to fame. But tocotrienol was known in 1960s. I was a mere 10-year-old then, but its utility and its abundance in nature was not known until at least 20 to 30 years later, and then another 20 to 30 years later before we now know what tocotrienol vitamin E is even beneficial. Hopefully we will uncover some of these in the interview today.
Right, gotcha. Okay. Because in the old days when I knew vitamin E, my history of it was that, the major exponents of it were the Shute brothers, Wilfred and can't remember his brother, cardiologists, and they were basically laughed out of cardiology for suggesting that vitamin E had any beneficial effect in cardiovascular disease. Dr. Lady Salento, an Australian GP, used to also tout its uses, not just for cardiovascular disease, but for many other uses as well. But then it fell into ill favor, and there was quite a few negative trials. There was the Chaos study, and it sort of, while seemingly positive, there were certainly its detractors, but there was many others. So it's sort of gone through this whole life cycle. So when
Yes.
did they know about tocotrienols, and when did they think maybe it's not the tocopherols that are the important part?
Okay. Let me see if I can paint a broad paintbrush on the timing. Um, Tocopherol was discovered about 45 years before uh, um, tocotrienol. So the discovery of tocopherol was 1922 by two pediatricians from UC Berkeley, like that. And tocotrienol was not discovered until the 1960s, like that. And when tocotrienol was first discovered, it actually was as early in 1962, 63, but it was so close in structure to I have a structure here. I know this is only an audio thing. This is for your concept. If you see here, where my finger is pointing, there's a double bond here, and double bond here again. And the last double bond is here. So because of these
Mhm.
three double bond, the tail is called triene, just means three double bond. A tocopherol would have the same tail, but the three double bonds would not be there. The antioxidant
Right.
head would be in here. A tocopherol and tocotrienol would have the same head, and this would be the antioxidant head. That's it. So because of the structure, they're so similar between tocopherol and tocotrienol. Even in the early 10 years, 20 years of tocotrienol discovery, they have other Greek letters. The four common one is alpha, beta, delta, gamma tocopherol. You will also see epsilon, nu, zeta, and
Oh,
phi tocopherol. Those tocopherol are
right.
actually tocotrienol. It was not until 2002 or 2003 they fixed it. So not only is the identification 40 years later, the nomenclature was also delayed. So that means it's almost as if that if we wait any longer, tocotrienol would have never been known. So I persisted with tocotrienol in my earlier career and then have stayed on in the last 30, 40 years to study it. So, and surprisingly and happily, it have differentiated properties from tocopherol, very different property. Today we know, and 30 years ago, 40 years ago when I started, I did not know. I just knew that the compound had different structure, slightly different structure, but the slightly different structure bear enormous difference in functions.
Right. Okay. So just going back, that's really interesting about the evolution, about the naming of it, the nomenclature. So it's basically like how tuberculosis used to be called consumption. So if you look for tuberculosis in the early medical papers, it's not there because it was called something different. But can you take us through that evolution of vitamin E with the concentration of alpha tocopherol? And whenever there was a negative trial, defendants used to come back and say, "Oh, you used the synthetic form, the DL alpha tocopherol, or you're concentrating on alpha tocopherol, not gamma tocopherol." You know, was there the the tocotrienols hiding in the background doing its work, but we were concentrating on these other molecules because that's all we knew?
Not so much hiding in the background. It's just that from the delay in terms of his 40 years after on his discovery and the misnomenclature, that's the timing of the tocotrienol. But for the tocopherol side, it's very simple. About 15 years after the discovery of tocopherol is known to be a very powerful antioxidant. It is known to protect lipids and fats in the plant. It's not a substance for people. It's a substance known in the plant. And they're found in nuts, anything that is rich in oil and fat. So it's known to protect the vegetable oil from going rancid. So it's known as a potent antioxidant for the fat. Now, then since then, people study animal cell line study throughout the 60s and 70s. A lot of study with tocopherol. Forget the tocotrienol for the time being. So when they did those studies, it looked like the more tocopherol they add on to the animal or the cell, the better the protection would be. And somewhere in the 1950s and 60s, you mentioned about the Schutt brothers in Toronto. They begin to give to patient. Apparently, it helped the patient a lot. So now you fast forward a little bit to the 1990s. So there were huge clinical trials that used 400 milligrams. Sometimes they use synthetic vitamin E. And initially they all use synthetic vitamin E. And after another 5-10 years, it didn't quite work. So they changed it to natural vitamin E. And then another 5-10 years passed, and still it didn't work. So if you sum up all the clinical trials from synthetic to natural vitamin E, they were all about alpha tocopherol. And that was when
Right.
they found out that at best it didn't work. at worst, it may do some harm. So then people begin to raise the question, could it be the gamma tocopherol that worked? But nobody was making gamma tocopherol. Gamma tocopherol is abundant in the plant, but nobody synthesized to make it for consumption purposes, not them. So now, in the middle of all this happening, I show up with others at early 1980s and discovered this from barley, a very a source that nobody cares about, and then from palm oil, and then we decided to do studies on it. So we were actually doing studies on it almost like in the shadow of tocopherol. And it's almost as if in the mid 90s, right when we were finding some interesting findings on tocotrienol, and all these tocopherol studies came crushing down, I thought our days of tocotrienol research is going to crush with the tocopherol. But I persisted.
Right.
The tocopherol went down. I continued to do research on tocotrienol, and then we found out that it worked on many chronic conditions. The tocotrienol does, but not tocopherol.
Gotcha. And I also have to ask about the antioxidant theory, because I've sort of, I waver with the antioxidant theory. So, you know, electron transfer happens. Oxidation is an essential part of life in the electron transfer chain. And then we talk about these antioxidants, but is it more of just a biochemical or an atomic level action that might even happen with Ventolin? But the real action, or the real important thing is, does it help Mrs. Jones's condition? So how much do we concentrate on the antioxidant theory, and how much should we now be really concentrating on endpoints, on not just markers, but actual benefits, human benefits?
Yeah. Let me answer the first part on the antioxidant theory. The benefits to a human life, I will touch on that. It's a very insightful question you have. The initial part about the antioxidant work was, it was very elegant. You have this tocotrienol tocopherol molecule is part of a ring and is able to satisfy itself to capture the free radical of fat that is easily oxidizable. It's very neat, it's very clear chemistry. They did that. And it showed up in fat oxidation. They did it on butter. They stressed the animal and is able to capture the free radical. So it fits the mechanism. And so I, as a young chemist and biochemist in the 1980s, I bought into that. So no shame in doing that. We just bought into that. And then later on, when the clinical trials fail, it's just like a domino, one after another. With alpha tocopherol, they were positing that the alpha tocopherol was be the end game in capturing the free radical. It didn't do that. And when it didn't do that, it raised a lot of doubts in people's mind. Could it be the free radical understanding, the antioxidant thing not working? Or it's just simply not able to bring it to pass in, I call it phenomenon. When it happened to people, it didn't work like that. I think that the free radical and the antioxidant theory hasn't gone away. I think that we were over enthused to say that the antioxidant theory is explaining everything. And so, but it did not explain everything. So when we conduct clinical trials now, of course, hindsight is 2020, like that, we would do antioxidant study of fat, of lipids that are in the blood, the MDA mevalonaldehyde drop, the antioxidant. I know you gave up some ROM and ROS thing. We sometimes measure that, but we limit it because if you do this, then you are able, then the comments that you can make, Andrew, would be phrase that you say proxy. So words that people use would be a proxy to, predictors, biomarkers, indicators, or even blood enzyme. None of this is necessarily bad. So we decided that when we start to do clinical trials on chronic conditions, right now, of course, we are talking about 20, 30 years after. So I'm not talking in any boastful manner. It's just that we learn from the past, and I don't want to repeat things that people do and still harping on the antioxidant thing. This is not to say that tocotrienol is not. We have so many studies. If you ask me, I can tell you later how tocotrienol is superior as an antioxidant to tocopherol. There are actually hundreds of studies. They're superior, but I don't want to posture that to you. When we study it, we study chronic condition, people, clinical trial of type 2 diabetes, pre-diabetes, people with fatty liver disease, metabolic syndrome. We study all these. And now we are conducting study on obese men and obese women study, severely under stress. So when we study, let's pick up one, type 2 diabetes. The patient is going to ask, Dr. Tan, does it work or does it not work on my sugar? They are not going to ask, how does it work as an antioxidant? Just don't say
No.
anything, yes or no to sugar. They are going like that. And then for the fatty liver people, they're going to say, do I have fibrosis of the liver or not? Is my liver enzyme increasing or not? So we studied that dramatically, and we found that they are still a proxy, but they're closer to the problem organ area. And right now, we are doing a third clinical trial on fatty liver. We already done all the other ones. The third one, we're going to have a CAT scan or MRI on the liver. So those are not giving you proxy. You either see
No.
fat deposit or you don't see fat deposit. So we do that, but we still measure C-reactive protein, for example, to measure inflammation. We study mevalonaldehyde for measuring fat, and then we measure oxidized LDL to see if the LDL, to see if it's just LDL, which is a potential atherogenic, but oxidized LDL is definitely atherogenic, to see if the oxidized LDL is increased or not. You follow what I mean? So we still
I
do
do.
some of those, but they're not our end game anymore.
Gotcha. Okay. So with those papers, when I was doing the research for our podcast, whatever the total thiol levels and things like that, they're just a proxy, and we may as well use ALT, AST, GGT, your liver enzymes. We may as well use CRP, more orthodox method. One that I'm not familiar with was the forgive me, the mevalonaldehyde. Is that right? Mevalonic. I'm used to mevalonic acid.
Mevalonaldehyde. Mevalonaldehyde is fatty acid, the final breakdown products of fat.
Right.
So the final breakdown product of fat, they are stable and they're measurable. And then there are some intermediate one. It just slipped my mind. It's oxidized. They're kind of like a fatty acid, but they're stable enough that when you measure them, it's reliable. Lipoxide, something like that. We measure that occasionally. We also measure deoxyguanidine base, which is a DNA base that is stable to do this. We have those, Andrew. We measure them. I know time doesn't permit us because we only have a short time. We measure this and they consistently drop. Why? Because tocotrienol is a powerful antioxidant. They're working. But if were to be a college professor, if I were to publish a paper with do this, I'll get something to publish clearly differentiated from the control. But we are trying to make a product that is useful to people. So we have to figure out a way to study. Does it work on improving the insulin? Does it work on managing the sugar? Does it work on reducing the triglyceride? Those parameters on prediabetes and diabetes. Does it reduce scarring tissues on the liver for fatty liver? Those are the things. And then in the current obesity study, we actually going to get biopsies of the adipose tissue because they are obese people. And then we're going to study the leptin and adiponectin. These are the mark. These are not the marker. These are the actual reagent that helps the protein that help it to burn the fat or store the fat. So we are directly studying something like that, and they are not necessarily easy to do. And you have to get institutional approved board to do it. It's easy to do this with animal study. It's not easy when you come to human being. If it were to be, we would have biopsies on all the organ tissue. We can't do that. We can only get biopsies tissue when people is clearly sick in that area, like people who have liver cancer. Then you can get the biopsies done. But otherwise, it's a huge desire to know, but we cannot access it. And by the way, when we do the adipose tissue, we know, for example, from animal study, the tocotrienol is deposited into the adipose tissue. So now with that adipose tissue, we'll be able to see how much of the tocotrienol is stored when people take it. So that's a true bioavailability measurement as opposed to an emotional one on the blood.
Yes. And oh my goodness, I could go so many ways here with so many other supplements that speak about bioavailability when they're not. They're talking about absorption. Thank you for covering that. But just a last question, and I hate to be the sort of devil's advocate here, but I'm really curious, and that is, why not give the alpha tocopherol or beta gamma tocopherol with tocotrienols? I was looking at the molecular structures of them and how they sort of bend apart the if you like the fatty acids in the cell wall. Is that part of how they work? Do we need to blend them together, or should we just forget the tocopherols and use tocotrienols from now on?
Okay, I will answer the second one first. The tail of a tocopherol here, they do not have the 3 double bonds. Here, the tocopherol tail is longer. The tocotrienol, because of the 3 double bond, the tail is shorter. So therefore, the tocotrienol is able to circle the cell membrane much faster, 50 times faster than tocopherol. It's basically spinning around the cell. The tocopherol still move around the cell, but it's moving 50 times slower. So therefore, this is a metaphor, works in the US. I'm not sure if it works in Australia. We have local police. The local police are confined in the area of the town. They do not cross to the next town. The people that cross to the whole state, they are state troopers in the US. And the people that cover the whole country, they're FBI agent. So FBI agent covers the whole country. State trooper covers the state, each state, and the police cover this town. So I think of a tocopherol, because it's moving slowly, it captures the free radical in the town because it's not moving very fast. Whereas a tocotrienol, the tail is shorter. It's able to spin around the cell fast, 50 times faster. Therefore, is able to capture the free radical of the entire state, essentially covering a much larger surface area. So in that way, that's why it is a more potent antioxidant. Now, let me answer your second question. Do we need tocopherol? We do not need tocopherol only in this sense. Only in the sense that alpha tocopherol blocks or interferes with the function of tocotrienol. This is repeatedly shown in the last 20 years in cancer, in diabetes, in lowering cholesterol. And so those are, I just gave you some examples. And also, high amount of alpha tocopherol seems to be negative. Some of them you mentioned on the clinical trial. But I care mostly on the first one, because tocopherol interferes with the function of tocotrienol. So if you wish tocotrienol to have cardiovascular benefit, metabolic syndrome benefits, diabetes, and cancer, then it is best not to put in tocopherol that interferes with the function. So now I'm sure the audience is wanting to know, why does tocopherol interfere, alpha tocopherol interferes with the function of tocotrienol? There are several mechanisms that people propose. The simplest one it is, of the 4 tocopherols and 4 tocotrienols, only alpha tocopherol has a transport protein, meaning that it has a rite of passage that a protein will hold on to the alpha tocopherol, it goes right in. All the remaining 7 tocopherols and tocotrienol, they will go to what we call passive diffusion, engineering term. A difference in concentration to put over, but alpha tocopherol has a transport protein. It has a rite of passage, just like vitamin D, just like retinol, vitamin A. So alpha tocopherol is the only one. So if you consume food with alpha tocopherol, all the alpha tocopherol will go in without any assistance because of the transport protein.
So, okay, so that answers so many questions in itself. But also, what about the different tocotrienols? Do they interfere with each other? Should we be favoring certain ones over others?
So far that we have tested, only the alpha tocopherol interferes. Well, so far it's clearly tested. Alpha tocopherol interferes with the absorption of gamma tocopherol. If you Google, you find lots of studies. 1. And 2, alpha tocopherol interferes with the functions of all the tocotrienol.
Of all of them. Okay, so now going on to the tocotrienols, should we be favoring certain tocotrienols over others? Do they have varying actions?
Mm-hmm. That's a good question. In the late 1990s, early 2000, at the time, researchers and scientists were curious. You have 4 tocotrienol, alpha, beta, delta, and gamma. So they compare them individually. And when they did, the rank order of efficacy is delta is more active than gamma, in turn more active than alpha. And beta tocotrienol is almost not active at all for most of the time. So once again, delta is equal to or twice as active as gamma, typically. And then in turn, gamma tocotrienol is about anywhere from 2 to 10 times more active than alpha tocotrienol, with very few exceptions like that. So now, having said that, the unique finding of annatto tocotrienol is this. When I first took annatto tocotrienol to analyze, the annatto, if I just move my head, you see here, see the red color thing here, those are keratin. Yep. And keratins are very unstable. I expected that something is protecting the keratin. At the time, I didn't know what it was, and thinking that it's probably a polyphenol. And when I analyzed it using high pressure liquid chromatograph a while back, long time back, and I was surprised I only saw 2 peaks. And I thought it must be alpha tocopherol somehow because plant makes alpha tocopherol or gamma tocopherol. I found neither alpha tocopherol nor gamma tocopherol. Then I only found delta tocotrienol and gamma tocotrienol. Then I remember that was about the year 2000. Then I thought, wait a minute. Delta tocotrienol in all the other animal study is the most potent, and gamma tocotrienol is a close second. And now when I analyze it from annatto tocotrienol, it's got 90% delta and 10% gamma. So it has 90% of the most potent vitamin E and
Yeah.
10% of the second most potent. Then I immediately called my colleague at the time in University of Wisconsin. And I remember Dr. Qureshi said, Barry, if tocotrienol is ever going to work on human being, your annatto tocotrienol better do. If it doesn't, then all cause for tocotrienol work is useless. So from then on,
Right.
I committed my life to continue to purify the tocotrienol. So now you fast forward 25 years, we have lots and lots of clinical study, and really grateful to report in everything that we have done clinical trials, it worked. This annatto tocotrienol is supposed to be a drug, but we are not making it a drug. We just do the study and publish it. And so you see that if you go on our website, we cite all the papers that we've been studying, and they're continuing to come. So I'm eternally grateful. And this is something I just stumbled on when I was in South America looking for totally something else in that part of the Amazonia. Remember, Andrew, there are 50 million chemicals on earth, and I happened to stumble onto a plant that happened to give me two of the most potent thing. I'm really grateful if I can pass this thing on to be of use to other people. That would be such a fantastic way to finish my career. So I'm still working on this. So until the studies come through. So there you have it.
Well, you know what? It's one of the things that impressed me about you when I was reading your book, and it was your love of plants. And I remember the story. You were in South America looking at some plant, and there was one annatto plant, and you found that, and you were just drawn to it. And you said something very interesting there as well, which I'll get back to a little bit later. But before we do that, when we're talking about annatto versus palm, like the palm oil, has huge ethnobotanical issues. What about annatto? Is it grown ethically? Is it causing the destruction of virgin forests like we're seeing in Indonesia and things like that?
Thank you for asking that question. I don't get asked that question often enough. When you think about palm oil, it is a global vegetable oil, much less expensive than soy oil. And remember, soy oil is already dirt cheap
Ooh.
because in the US, we use soy oil as a byproduct of soy protein and corn to feed the animal. So the vegetable oil coming from soy is already cheap. And against that, palm oil is even cheaper than soy oil. So for the part of Southeast Asia, particularly Indonesia and Malaysia, there's huge amount of it. And then you and I read the same thing, deforestation, and then ethnobotanical problem and all this like that. Now, if you stop there for a moment, you flip to annatto. Annatto is a drop in the bucket because annatto is grown for the benefit of the color. If you go to your Australian supermarket to buy a hunk of cheese, that beautiful orangey yellow color is annatto color. If they do not put synthetic color, if it's synthetic color, then
Right.
it's worse. But if it's normal color, it would be cheese. Sometimes they use that for coloring ice cream, meat to systematize the color, but it's famously used for coloring cheeses like that. So for coloring cheeses, compared to a vegetable oil like palm oil for human consumption, and palm oil is also used as a biodiesel. So that means annatto usage will pale compared to it really literally a drop of water in the ocean compared to palm oil. So it almost have, and also people, there are no massive annatto plantation. There's no such thing. They are small sharecropper, subsistent farmer that they sell their annatto seeds to the processor. The processor process the bixin. We use the remaining of the annatto oil, and then we purified it further to make it. It's almost as if that if it is not, then after they process the annatto color, it will be thrown to waste. So we're actually saving what is not used to get the tocotrienol. So it's hardly
Yeah.
disrupting anything in nature.
Thank you for answering that. That eases my mind. Barrie, we have to get deeper into the trials that you've done because they're really important. Now, you were talking about liver enzymes and you were talking about diabetes. We've got a huge issue of non-alcoholic fatty liver disease. It's estimated to be 30% of the Australian population, and we're a lot of drinkers. So, so, tell Tell us a little bit about the work that you're doing with non-alcoholic fatty liver disease and indeed other liver diseases, cirrhosis, things like that, but also diabetes. These are very important.
Okay, the liver disease thing has a story in and of itself. It was a famed Ohio State University professor, and he was needing to do tocotrienol in head trauma, stroke patient. But the National Institute of Health said that to give him money, which they were going to give him the grant for, he need to give human subjects to know that these tocotrienol is found in different organs in the body without him. So he had to figure out how to do that. And the university happened to say to him that, well, we have a liver failure patient. Remember, he's studying trauma of the brain, but the only patient that they have is end-stage liver failure patient. You probably know where I'm going with this. And then they're not expected to live. So they give them the tocotrienol, and then they would not be expected to live. I don't remember the time. Let's say 3 months after they are normal. Surprisingly, for the one that did die, they were able to show that tocotrienol were found in different organs on the cadaver tissues. Surprisingly, half or so of the patient didn't die. So they have an accidental finding that the tocotrienol helped to improve the liver. So it was an accidental find. I did not find it. Somebody else found it with the palm tocotrienol, which is about 25% tocopherol and 75% tocotrienol in the palm. So I surmise that if I gave them annatto tocotrienol that is free of tocopherol, it ought and should work better than palm tocotrienol. That's when my opportunistic entry into this is. So I didn't. So when we started on that, and sure enough, the first study was for 3 months. The liver enzymes dropped. And then we found out that they drop about 10 pounds. Nothing to sneeze at for people who have fatty liver because they're overweight. So we did a 6-month trial. They continue to drop their weight. This is not a weight loss product, but their weight dropped, nothing to sneeze at. And the liver enzymes continue to drop. The C-reactive protein drop. And so we then did liver scarring tissue and the liver, and then liver fibrosis. They also reduced from the scan that we have. So now we're finally doing a 12-month study to do this. And with the 12-month study, we're going to have a CAT scan or MRI. And with that, I'm done. I'm going to bury the hatchet. I've done everything that I could. Remember, we're not making a drug. We wanted to show this would work. That's on the fatty liver thing. And we did not study people with cirrhosis, but we did do in the you asked me other liver disease. When we did do the study, we excluded people who have hepatitis C, which is a virus cause of a liver condition, which clearly can bring cirrhosis if the liver succumb. And so about 9 to 12 patients were excluded from the study. Unbeknown to me, the investigator gave them tocotrienol. They are not part of the study. They were excluded from the study. And then some years later, they published the work. I said, hey, what's this about? So they told me after the paper was done, and they found that even for people who have hepatitis C, the tocotrienol would still work to reduce the damage on the liver. So if you ask me, what tocotrienol
Wow.
can do for the liver. It is a liver hepatotonic thing. We did not study.
Mm.
We hope someday we can do a liver cancer study. All the cancer study in Denmark currently are colon, lung, breast, and ovary cancer, but not on liver cancer. So that's on that part. I want to address the second one because you asked me to, on type 2 diabetes. So we gave to people about 250 milligrams, not very high doses. The fatty liver was on 600 milligram. The type 2 diabetes, we studied it for 6 months, which is long enough. The sugar dropped, the insulin sensitivity increased, and then there's a measurement that the American Diabetes Association support is a HOMA IR that stands
Yes, right.
for homeostasis. It basically is a measurement of the sugar and the insulin together. So when you map this together,
Resistance, yeah.
and the HOMA IR also would drop. So I know the HOMA IR drop, insulin sensitivity increase, and A1C, which is measurement of sugar over 3 months, also drop. And the emotional glucose overnight fasting also drop. And then we thought, well, I'm a happy puppy because all these are direct measurement of it. Of course, we also study the mevalonaldehyde. We also study the C-reactive protein. We also measure the weight, the drop. We also measure the triglyceride. All these secondary markers also drop, but the main primary markers as it pertains to diabetes drop. So right now, we are studying pre-diabetes. So in other words, they're short of being diabetic. So that study, we were indicated that it's promising, but the study has not been published. So pretty much in the entire spectrum of metabolic syndrome, it helps. In other words, pre-diabetes, and then diabetes, and then fatty liver, and then NASH. Fatty liver is NAFLD and NASH. So we have not gone all the way to study cirrhosis. We are hoping to do a cirrhosis study in Argentina. As you know, Andrew, it's easy to say what study need to be done, but it's hard to design and even longer to wait. So we are thinking to do a liver cirrhosis or NAFLD study in Argentina. So we don't know if that's going to pan out. But as far as I'm concerned, it works on liver. It works on diabetes, and now we are doing it on obesity because obesity is also an epidemic in the US now. So,
Right. And then obviously following on from there would be cardiovascular disease. Something that really interests me, and I only recently found this out, was another compound in annatto. And I am going to read this out because I will murder this word if I don't. But that is geranyl.
yes, it's a
Geranyl.
general
And
journal.
and
I think, yeah.
so what I was really interested in here was that it's an isoprenoid. And what interests me there is its association with CoQ10, which is used commonly for cardiovascular disease. So
Yes,
where do we go here with annatto and cardiovascular disease?
yes. Let's say, this would be a CoQ10. So the CoQ10 ring is here, and the CoQ10 tail is exceedingly long. You can see here,
Yeah.
and then about here, where my finger is pointing here to here, that is GG. So 2 GG will be here, 2.5 GG would be here. So the entire 2.5 length of the tail of CoQ10 is GG. That's how the body use a GG to make CoQ10. If I'm wrapping it here, this is a pure cartoon. If this is tocotrienol here,
Yep. Yep.
and this is the ring of the antioxidant of tocotrienol, the entire tail of tocotrienol is GG. human being cannot use GG to make tocotrienol. Tocotrienol not making it, but the plant use GG to make the tocotrienol. So GG
Right.
is used in the plant to make tocotrienol. In the human body, GG is used in the body to make 4 things to the best of my knowledge. One is to make CoQ10 that you mentioned. Skeletal muscle protein is used GG to make.
Sarcopenia.
Manoquinone 4, MK4, is made directly from GG. And the last one is to promote the production of testosterone, particularly of the elderly. I think we should leave the last one out. And MK4, if you read about that, is for cardiovascular health, is for anti-arterial sclerosis and bone health. And CoQ10 is for energy. So you can that. But the main thing would be for skeletal muscle protein synthesis. So let's take the skeletal muscle protein synthesis. When people take statin drug, it's supposed to inhibit the isoprenoid so that it does not make cholesterol, a good thing. But about several steps down, it is obligatory when it inhibits the cholesterol synthesis, it also inhibits GG that the body makes. So because it inhibits GG, therefore, the body also saw reduction of CoQ10. So if you see CoQ10 reduction for people who take statin, it's because statin inhibited the GG. That's it. That's the reason why CoQ10 dropped. But the main reason the cardiologist is worried about with the patient is really not CoQ10. CoQ10 is what you and I worried about because we are alternative and we are holistic. The doctor, the cardiologist is concerned that the patient would have back pain, trunk muscle pain, and muscle pain. Why is that? Because trunk muscle pain and back pain, they are skeletal muscle protein. And GG is required for the synthesis of skeletal muscle. So when you inhibit cholesterol synthesis by statin, it inhibits GG and thereby also reduce the ability of GG to make skeletal muscle. So therefore, if you add GG back to statin, it's fantastic because it makes CoQ10 reverse that and also reverse the damage caused myopathy by statin. This is very exciting.
This is very exciting to me as well, because what you're talking about there, skeletal muscle protein, you're talking about supporting at least and hopefully reversing sarcopenia. And it answers also something that happens with statins, and that is weight gain. So, Barrie, I could talk to you for hours. I'm learning so much. Would you be happy?
I want to say something, right? It is an Australian scientist, and if she hear this, she's probably tickle pink. She's based in Queensland. Her name is Dr. or Professor Jordan Irvin, and she did 4 groups of animal study. A control group, that means just normal rats with statin, second group, rats with statin and GG, and rats with just GG. So if you compare rats with GG and control group, she saw that the muscle power of the rat increased. So that would work on exercise people, exercise signs, or on the elderly to prevent sarcopenia. When she did the statin group, the second one, the statin reduced the ability of the force production. And when she compared the statin group and the statin and GG, she found that the statin and GG is able to reverse the damage caused by the statin. That study was
Wow.
only published last year by an Australian scientist
Brilliant.
in your neck of the wood. So it's amazing. This is not, and if
And in
any of interest to you, my folks here can send you those paper. If you want another time to do another interview, I would love to do that, to follow up on
Oh,
this.
please, I would love that. I would love, and I'm definitely going to get in touch with, is it her, Jordan Irvin?
Jordan yeah, Jordon Irvin is a she,
Yeah,
Jordan Irvin, and I think she's based in Queensland somewhere. I don't know the precise address at the
I
university.
will find her
She was,
out
yeah,
because
she was
I live in
was going to,
Queensland.
yeah, huh? What did you say?
I live in Queensland. I'm in Queensland.
Oh, okay. So you'll be, and we were wanting her to see if she could continue the study with us, but she has moved on to other studies, so she's not. Otherwise, we would love her to continue the study. But we are highly grateful for the seminal work she did, and we are having other people in Texas and elsewhere to continue to follow up on that study and to do some clinical trials on exercise science, on people that take statin, on the elderly population. So more to come. But the tocotrienol, because we did that earlier stage, so we have lots of study on tocotrienol, much less study on GG at this point.
Right. Well, I look forward to so many more studies coming out with GG, but also we're going to put up all of the show notes, and I'd love to put up as much research as we can on the tocotrienols, the delta gamma especially. Dr. Barrie Tan, thank you so much for taking me and us through not just vitamin E, but also the benefits of tocotrienols. It's cleared up so many aspects in myself that I was unsure of about vitamin E and its history, and it answers why we need to, bend and just leave tocopherols behind and concentrate on the tocotrienols. But thank you so much for joining us today on Wellness by Designs.
Thank you so much. Blessings.
And thank you, of course, for joining us today and listening to Barrie Tan. Remember that you can catch up on all the show notes on the Designs for Health website, as well as the other podcasts on your favorite podcast app. Thanks so much for joining us on Wellness by Designs. I'm Andrew Whitfield Cook.